Okay, so this is 6.1, properties of exponents, and this is going to take us the better part of this week to get it through, because what we're going to talk about today are the properties of using exponents, but then the application of it is going to take some time. So we have got 5 of these rules that we are going to go through today. And the first one is the zero exponent rule. And what this rule says is for any non-zero a value, because we're going to put some letters to it. So anytime this a is not 0, here's what happens. A to the 0 power is 1. I could take z, raise it to the 0 power. It is 1. 2 to the 0 power is 1. 1.65 to the 0 power is 1. 562,214 to the 0 power is equal to 1. And hopefully you're picking up what I'm putting down here is that any value, whether it's represented by a variable or a number, when it's raised to the 0 power, it is 1. And here's just you don't have to write this down, but here's a little background. If I have the number 2, and this is debated in the mathematical field all over, 2 cubed. Remember, that's 2 times 2 times 2. That's 8. And remember, there's really a 1 here. It's 1 times 2 times 2 times 2. I write the number 8 as just 8. I don't write it 1 times 8, although that 1 is really there. Same thing here. This is 1 times 2 times 2, which is 4. This is 1 times 2, because I take 2 times itself that many times, and to get that product, it would be 1. This is 1 times 2 times itself 0 times, and that just gives me 1. This 1 right here is the basis or the idea mathematically of why anything raised to the 0 power is 1. And I can do that with any number. This is debated on and on in math. For all intents and purposes, what we need to remember for Algebra 1 is whenever I see anything raised to the 0 power, that is a 1. But this is kind of the idea behind it and why. That's if I see something raised to the 0 power. You will also have negative exponents. We do not want negative exponents. We are not going to leave answers with negative exponents. For any integer, remember, an integer is our counting numbers, our 0, 1, 2, 3, 4, 5, 6, our whole numbers with our opposites, the negatives. Those are integers, no fractions, no decimals. So any integer n and any non-zero, so a number that's not 0, we'll say number, for any non-zero number a to the negative n is the reciprocal of a to the n power. So if I have some number, some non-zero number raised to a negative power, and I take the reciprocal of it, it gets rid of that negative exponent. Because remember, this is a to the negative n over 1. And by moving that below the fraction bar or flipping it, taking the reciprocal, it gets rid of my negative exponent. We'll put a little limitation on here. A cannot equal 0 because I can't have 0 in the denominator. It's going to make it undefined. So if I have something like this, 4 to the negative 2, I take the reciprocal of it to get rid of the negative. I flip it. This comes down, this goes up. 1 over 4 squared, which is 1/16. And we have to use that rule to do it. I can certainly take my calculator and put in 4 raised, my caret key, to the negative 2 power, and it tells me it's that number, 0.0625. That tells me you know how to put it in a calculator. That tells me nothing about you knowing the rules of exponents. I can certainly switch that into a fraction, but this is the step that shows me you know the rules of exponents. We've got to show our steps. Here's another example. I have negative 2 raised to the negative 4th. When I see this, I can't have this. Remember, this is over 1. If I move this down and this up, meaning I take the reciprocal of it, this is 1 over negative 2. Now it's to the positive 4th. And notice, my negative exponent changed, but this negative stays the same. This doesn't change. Only the exponent changes. And this is 1 over negative 2 times negative 2 times negative 2 times negative 2. 2 times 2 is 4. 4 times 4 is 16. This is 1/16. Three to the negative 3. And you can certainly take that and put it into your calculator, and it will give you that decimal answer, but that is certainly not what we're looking for. I could take that fraction answer and turn it into a fraction, and it tells me it's 1/27th, but this is why. Remember, that's over 1. I get rid of that negative exponent by taking the reciprocal, moving it down below the fraction bar. So that becomes 1 over 3 cubed. And that's where that 1/27th comes from. Letter C. Oh, wait, let's do this. Let's do negative 5 to the 0 divided by negative 2 to the negative 2. Now I can certainly go through this step by step. Anything to the 0 power is 1. That's what I'm going to simplify first. So I have 1 over, and now remember, this is like negative 2 over 1. If I take the reciprocal, this is like 1 over negative 2 squared. 1 divided by 1/4, because negative 2 times negative 2 is a positive 4. Dividing by a fraction multiplied by the reciprocal of 1/4 is 4. That is going to give me 4. I think there's a little easier way to approach this one, and I'm just going to do mine this way. You're certainly not going to go wrong doing it that way, but I want us to remember this is going to be 1. I know that's going to be 1. I'm going to simplify that first. 1 over negative 2 to the negative 2. Another way, and I think the easier way to clear these negatives when they're exponents. If it's in the denominator, the same thing holds true. If I take the reciprocal in my negative exponents in the denominator, by moving it up top, it's going to make it positive. So I could take the reciprocal from right here. This is -2 to the +2 over 1, and that gives me 4. I like this way a lot better than this way because I'm just dealing with less fractions. I try to clear those right away. Here's one where we simplify. Your calculator simply is not going to do the ones with the variables. 3 to the -2 times x to the -5 over y to the 0. That y to the 0, 1. These are separate terms. There's multiplication between here. They both have negative exponents though, so they both need to come down. This is going to get flipped. By flipping this or taking the reciprocal, I get rid of those negative exponents. 1 over 3 squared x to the 5th, 1 over 9 x to the 5th. And I got it. We've got to keep that in mind because if I have something like this, 4x to the -3rd, and I'm asked to simplify, this x to the -3rd is what has the negative exponent. That's what comes down. This is 4 times x to the -3rd. There's no negative exponent with that 4. The only thing that would come down would be this. This is 4 over x to the 3rd. And notice, the 4 stayed because there was no negative exponents. And when you have positive exponents with negative exponents, there's multiplication between there. You treat those one by one. I could have added a y here. That y would just simply stay up top. Product of powers property. We're going to say let A be a real number, a number we can take the square root of, a non-negative square root number, and m and n are integers. They're not going to be fractions. They're not going to be decimals. To multiply powers with the same base with the same base. The rule is add their exponents. We add them. So if I have something a to the m times a to the n, that is a to the m plus n. So if I have 4 to the 6th times 4 to the 3rd, my bases are the same. That's what I'm talking about with my bases. There's multiplication between the bases that are the same. I add my exponents. This is 4 to the 9th. And I'm going to leave that to 4 to the 9th because the rule of thumb we usually like to use in here is if I do 4 raised to the 9th, gives me a really big number. It's not that big. It's 262,144, but to me it's easier to leave that as 4 to the 9th. When it's in the hundreds, or maybe even just out to 1,000, I might write the number, but when it gets bigger than 1,000, I usually don't write the number, I leave it in exponent form. So that's the product. The bases are the same. I add my exponents. This can't be 5 to the 6th and 4 to the 3rd because my bases aren't the same. The rules only hold true if my bases are the same. Now we'll do a quotient. Product, multiply, quotient, divide. Quotient of powers property. I'm going to say let A be a non-zero real number again. A non-zero real number. I'm going to say M and N are integers again, meaning what's up here is not going to be a fraction. We'll get into those, but those are integers. To divide powers with the same base. To divide them, hopefully your intuition is telling you you would subtract, because the opposite of subtraction is multiplication. And when I have a product and I add, if I have a quotient, I would imagine I would do the opposite. And I do subtract. So here's what I got. A to the m divided by a to the nth. This is a to the m minus n. Bases are the same, subtract the exponents. I have 4 to the 6th divided by 4 to the 3rd. My bases are the same. 6 minus 3 is 4 to the 3rd. 4 times 4 times 4 is 64. Bases are the same, I subtract my exponents. There are certainly all sorts of caveats that are going to go with this, but this is the basic idea. When my bases are the same, I can subtract my exponents. Power of a power. We'll say let A be a real number. Let A be a real number. And M and N are integers. And again, I don't have any fractions or decimals in there as my powers. Your rule is going to be to multiply the exponents. So here I have some number raised to a power, and that whole thing is raised to a power. That is going to equal a to the m times n. So if I have 4 raised to the 6th, and that whole thing is cubed or raised to the 3rd, I do 6 times 3. That is equal to 4 to the 18th. You've got something raised to a power, power to a power, I multiply them. Say this is negative 3x to the 3rd. Remember, this is negative 3 times x. And both of these have exponents on them. Even though they're not there, this is still power to a power, and I have to distribute to both of them. This becomes negative 3, 1 times 3 to the 3rd power, times x, which is to the 1st, and 3 times 1 is 3. Negative 3 times negative 3 is a positive 9 times 3 gives me a negative 27 x cubed. Thing to take away here, when I have a power to a power, I have to multiply both of them. Z to the fourth raised to the negative 3. Doesn't matter that this is negative. I can still certainly do power to a power, which gives me z to the negative 12. I can't have that negative exponent, so to get rid of it, I move it below the fraction bar or take the reciprocal. This is 1 over z to the 12th. Now I also could have gotten rid of this negative exponent by bringing this whole thing down below right away. I could have done this, 1 over z to the fourth. Now that would be a positive if I bring it down below the fraction bar. I would still use power to a power. 4 times 3 still gives me 12, but it's just already in the denominator. I do not care which way you do that. We're going to look at one more example, bringing it all together. I'm going to say 3c over 4 to the negative 2. Remember, this whole thing is to the negative 2. Gets distributed each way, to the 3, to the c, and to the 4. And I could certainly do this out. 3 to the negative 2, c to the negative 2, over 4 to the negative 2, just doing power to a power. That means to get rid of these negatives, this all comes up, this all goes down. 4 squared over 3 squared times c squared. That just got rid of my negative exponents by flipping it. 16 over 9c squared. And I would have to reduce 16/9 if I could, but it doesn't reduce, so I leave it. Another way you could have done this is right away, if this negative is to everything here, I can flip this right now and do it that way. That also gets rid of that negative. I still distribute it to all three things in there, but that's 4 squared over 3 squared c squared, 16 over 9c squared. I get the exact same thing. Different ways to do each of these. There is our introduction to the properties of exponents. Again, these take some practice. We're going to work on these assignments the next couple of days. Be sure to jump on the Meet, and we will go from there.